Hello, dear students. I am Samir Velankar. I welcome all of you to this third video on programming of singly linked list. It is amazing, isn't it, that we are learning one program over the third video now. But the challenging part of this is that we are learning many fundamentals which will help us in understanding complicated data structures like doubly linked list, binary tree, graph, and many more. So the third video over here on this program is going to discuss how to delete a node from a singly linked list. In the first video, we saw how to insert. Second, we saw how to display. Now we are learning how to delete a node from a singly linked list. Now, if we want to delete some node in a singly linked list, we must tell which value we want to delete. Observe. So while calling delete node function, we pass the value. So if 20 is present, note my words, if value 20 is present in the linked list, then that node which stores value 20 should be deleted. And if 20 is not present in the linked list, let's say that user is bluffing that please delete 20, but 20 is not there in the list, then delete node should print an error message, cannot find such value in the list, so delete is not possible. Also, we will have to pass address of the first pointer. Remember, first is local. First pointer is local in main. So delete function cannot get the access to first. So we will pass address of first, which will be copied in pointer to a pointer. So let's see what is delete node function, how it runs. Now let's come to delete node. Here is void delete node function. It's going to delete a node and it's not going to return any answer, any value. And there is pointer to a pointer and it can point to a node. Now this pointer P is literally going to get address of first, isn't it? Address of first. So address of first is 500 as you observe in the picture. So P is a new pointer which is actually a pointer to a pointer which will store address of first. Address of first is 500. So P will point to first. Now onwards in the function, if you write asterisk P anywhere, then it will mean same as first. All you know all this, but my habit of repeating a few things. Okay, now to delete a node, the first thing necessary is to search. We will have to search the value x in the linked list. Note that x we are assuming here is I think 20. I forgot. Let me check. Yeah, 20. So we are supposed to delete 20. X is 20, isn't it? And note that 20 is present. 20 is present in the list. So the node which stores 20, this node, should be deleted. But what do you mean by deleting 20? If 20 is deleted, then the next pointer of 10, observe, next pointer of 10, this next pointer where the mouse cursor is, cannot point to 20 because 20 is going to get deleted. Then next pointer of 10 should not point to 20, but it should point to 30. I hope you have followed the trace of the cursor. Next of 10 should point to 30. If we do that, then 20 will be ultimately deleted because next of 10 will point to 30, 30's next will point to 40 and so on. So 20 is bypassed. Then 20 will be disconnected from the list, and that is what we call by deleting a node from singly linked list. But first things first, if you want to delete 20, we will have to search where is that 20 in the singly linked list. Isn't it so? So for searching, what we have done is, up here, we have declared two pointers, A and B. A and B are pointers to node. So in the memory, there are two new pointers, A, which is pointer to node, B, which is also pointer to node. That means A and B can point to any nodes, isn't it? So now let's start searching. We are still not discussing deletion. Deletion can happen only after searching 20. Now let's start this. A equal to B equal to first. Listen, I am reading asterisk P as first. Asterisk P is same as first, isn't it? Okay. So A and B are the pointers which will point wherever first points. So A will point at the same node where first is pointing, and B will also point at the same node where first is pointing. So both point to 10. Now in the algorithm, in the methodology to search a node, we want to search 20. The procedure will be that we are going to use two pointers A and B for searching. You might be surprised why two pointers. Basically, the algorithm or the procedure will work like this, that B will always follow A. That means B will be always one node behind A. So suppose A moves to 20, let's say A moves to 20, then B will remain at 10. Suppose A moves to 30, pointer A is at 30, then B will be at 20. Suppose A moves to 40, pointer A is at 40, then B will be at 30, and so on. So B will be one node behind A. Let's see what's the advantage of that. Okay. So A and B start at first. Now hang on in this while loop. While is having two statements. Now while should repeat only if A arrow data is not equal to X. Remember, X is 20. I will better write it here. The data that we want to delete is 20. So let's check the condition. Is A arrow data really not equal to 20? What is A arrow data? Follow the cursor. A arrow data here is 10. A arrow data is 10. A is pointing at 10. So A arrow data, which is 10, is not equal to 20, isn't it? What that means is the node at which we are currently, at the node at which A is pointing, the node at which A is pointing is not storing 20. Check my words. The node at which A is pointing, A arrow data, is not storing X. So we don't want to delete this node. Then we enter the while loop. As the condition is true, we enter the while loop and B becomes equal to A. This is again pointer equal to pointer. That means B will point wherever A points, isn't it? And anyway, B is pointing wherever A points. Surprised everyone. Then why is this line written? B is equal to A. Anyway, B is equal to A. Well, B equal to A statement may show its colors during the next repetition, but right now anyway B is equal to A. So forget it. Next line is A should point wherever A arrow next points. You know the meaning of this line. We have come a long way now. So A will point wherever A arrow next points means A will point to 20. A arrow next is pointing to 20. All right. So A will discontinue to point to 10, but A will point to 20. A is equal to A arrow next. But note we have not changed B, isn't it? A has moved ahead due to A is equal to A arrow next, but B is still at 10, correct or not? B is still at 10. All right. Now let's go back to while and ask, can we repeat? Listen, we can repeat if A arrow data is not equal to X. Now what is A arrow data? Clearly see, clearly observe. A arrow data is now 20. So I'll better write it here. A arrow data, check this. A arrow data is 20. And is 20 not equal to 20? That's false, isn't it? That means the data to which A is pointing is the data which we want to delete. So not equal to is false. In fact, A arrow data is equal to X. So hence the while loop breaks. What do you understand when the while loop breaks? We are out of this while loop. We are sure that A is pointing exactly to that node which we want to delete. Are you understanding? And B is pointing exactly to that node which is before the node that we want to delete, just before the node that we want to delete. Look how B is pointing to predecessor of 20. All right. So we are now ready to delete 20, isn't it? But wait. Before that, let's ask, what is the condition of A? After the while loop, we will ask if A is null. Now listen, if A is null after the while loop, then we are sure that the value is not found in the list. I'll tell you why this happens. But right now you ask yourselves, is A null? Not really. Check the diagram. A is pointing to 20. The while loop stopped when A was pointing to 20. So A equal to null is false. So these lines, if a equal to null is false, and this code will not run. So ultimately we are at the next if. Now you see, in the if we are asking if a, the pointer a, is equal to first. Is pointer a equal to first, we are asking, because asterisk p is first. Is it? Is pointer a, is a pointing where first is pointing? No, no, no. A is pointing to 20 and first is in fact 10. So this condition is false. Now this condition has been written because we have to deal with the first node deletion. Deletion of the first node specifically or specially we will have to deal this condition. Because if we delete the first node, then the first pointer will point to the next node. We will have to change the value of first, isn't it? More about this later. But anyway, a equal to first is false right now. Okay. So we are in the else, because a equal to first is false. So we are not deleting the first node. We are in the else, and b arrow next equal to a arrow next is written. Check that. B arrow next equal to a arrow next. So what happens really? Trace it. B arrow next. B arrow next, that is next of 10. B arrow next should become equal to a arrow next. What is a arrow next? Come on. A arrow next. A arrow next is nothing but 30. That means B arrow next, this pointer, 10's next pointer should take a jump and it should point to 30. Very nice, isn't it? What that means is this association of 10 and 20 is broken. Are you understanding? How can 10's next point to 20 now? Because 10's next is asked to point to 30, isn't it? It should point to now 30. So 10's next points to 30. I hope you are understanding. 10's next is now pointing to 30. Now you tell me what is the condition of this linked list. If you start tracing the linked list from first will take you to 10 and 10 will take you to 30. I hope you are understanding. 30 will take you to 40, 40 will take you to 50 and so on. So where is 20 in this list? This 20 is as good as not there. This 20 is as good as deleted. It's not the candidate. It's not the candidate of the list, because you always consider the list from first, and first node is now directly going to take you to 30. So 20 is as good as deleted, but you are not happy, I am sure. You will say, sir, I agree that 20 is deleted, but 20 is still there, isn't it, in the memory? Don't worry. After p after b is equal to p arrow next, after this line, b arrow next is equal to a arrow next, we will execute a statement free a. Now what does free a mean? Free the memory to which a points. Free that memory which was allocated wherever a points. So the memory of this node, memory of this entire node will be released. We are returning this memory to operating system. So this node is literally freed. This node is not there in the RAM now. I hope you are understanding. Yes, everyone. Look at the list that we are having. 10's next is 30, 30's next is 40, and so on. And after free A, obviously the next line is end of the delete node. Of course, when the delete node ends, needless to repeat, all these local pointers A and B, which were asked, which were declared in the delete node function, will be erased from the memory. Even P will be erased. P was a local parameter. This is erased from the memory. Sure, you understood, isn't it? Okay, let's execute this delete node again. All right, I will redraw the list. Assume that we have got the same list again. Let's say 10's next is pointing to 20 and 20's next is pointing to 30. And assume this time we don't want to delete 20, but we want to delete 10. So what's so extraordinary about that? Why am I discussing this? Note, if we want to delete 10, we will search 10 first of all, and 10 will be found right at the first node, isn't it? And we are going to deal this condition specially using special if statement, because deleting a first node is a special case. Why it is a special case? because we have to change the position where the first pointer points, isn't it? The first pointer is the header pointer to the list. And if we delete the first node itself, we will have to tell first pointer that you better don't point to 10. 10 doesn't exist anymore. So you point to next node. Okay, let's try to delete 10. Assume that main calls delete node by passing address of first. So address of first is copied in the pointer to pointer as usual. Pointer to pointer will store 500. It points to first. Now onwards asterisk p is same as first. In the function delete node, we have declared two pointers a and b which can point to any node. Check, keep reading the delete node function. A and b are the two pointers which can point to any node. Next line says A and B should point wherever first is pointing, isn't it? So A and B will point wherever first is pointing, means A and B both will point to the first node. A and B will point to the first node. Okay. After that, we ask while loop, can we repeat? While will repeat only if A arrow data is not equal to X. Listen, X this time is 10. We are deleting 10. And you notice A arrow data, check this, A arrow data is 10, isn't it? So the data at which data at which A is pointing is 10. And we want to delete 10, so not equal to is false. So this while is not going to repeat at all. It will break. And when while breaks, we are going to check is A null. Now this condition has been written is A null because we want to know whether the value was not found, isn't it? But by the way, we will discuss this condition after some time. Right now it is enough for you all to know that A is not null. Check the picture. A is not null because A is pointing at 10. So the while loop stopped when A was pointing at 10. So we are out of this if. Now we reach the next if and we ask is A equal to first? Asterisk p means first, and A really is equal to first. Note A is pointing to 10 and first is pointing to 10. Both pointers are pointing to the same node. That means A is equal to first. What does that mean is we want to delete the very first node. First node has to be deleted, isn't it? I hope you got this. Now if we delete the first node, we simply can't free it because the first pointer, observe, was pointing at 10. Now first pointer should point to 20. The next node should become the first node, isn't it? So what have you said? If A is equal to asterisk P, we will say first, check the left hand side here, first equal to A arrow next. Because asterisk P means first. First equal to A arrow next means first will not point to 10. First will not point to 10. But where will first point? Yes. First will point to A arrow next. Check A arrow next is 20. So first pointer will now point at 20. That's it. We want this because 10 is deleted. So who is appointed as first node now? 20 is appointed as first node. Obviously the successor of first. Successor of 10 is appointed as the first node. Assume that the address of this node is 2000. Then first will be no more 1000. It will now store the address of the node which is stored at 2000. And after asterisk p equal to A arrow next, that is after advancing first to the next node, this is advance first, first, advance first to next node. And first is at 20 now, we will free A. What do you mean by that? Free the memory to which A points. Free the memory to which A points. That means free this node. Return 10. Return the node which was storing 10 back to operating system. We don't need this anymore. And the memory is cleaned. Isn't it? And after this after free A, obviously the else will not run. Because if was true, and if else doesn't run, if this else doesn't run, then the delete function ends. So if the delete function ends, lot of things are cleaned, as you know. A and B will be cleaned because they were local pointers, and even P will be cleaned. So what is the list we are having? Come on, look at this. This is so interesting. The list we are having now is first is now pointing to 20, 10 has gone, and 20 is pointing to 30 and so on. I hope you got this. I hope. Okay. So let's see, answer a few questions. I will take a pause in the video. Suppose we have a linked list like this. 10, 10's next points to 20, 20 is next points to 30, 30 is next points to 40, 40 is next points to 50, and 50 is next is null. And first is pointing to 10, the node which stores 10. So suppose if we are interested in deleting 30, assume we are deleting 30, that is x is 30. Then I'm not showing all the details of pointer to pointer and all that. Come on, you know that now. If we want to delete 30, then we will start two pointers A and B starting at 10. Then we will go into the while loop. Here is the while loop, isn't it? While loop. We will continue the while loop as long as A arrow data is not 30. X is 30 now, isn't it? As long as A arrow data is not 30. So you can see A arrow data is not 30. So we will enter the while loop and B will become equal to A. Anyway, B is equal to A. Check the cursor place. B and A both are equal, both are pointing to the same node. So nothing happens due to B equal to A. But then A equal to A arrow next means A will move to the next node, isn't it? So A will discontinue to point to 10, but A will point to 20. I hope you got it. But B is still pointing at 10. B is the predecessor. Now if you go back to while again and recheck the condition, check the condition in the while loop. While A arrow data, what is A arrow data by the way? 20. Observe the picture. A arrow data is 20. A is pointing at 20. Is it not equal to data that we are deleting? Data we are deleting is 30. Yes, it is not equal. So we will go into the while loop again and B will become equal to A. Look how B becomes equal to A means B will no more point to 10, but B will also point to 20. B becomes equal to A. Are you understanding? How B carefully follows A. Okay. After B equal to A, the next line is A should become A arrow next. That means A will no more point to 20, but A will point to 30, isn't it? But B is still pointing to 20, the predecessor of 30. Now let's get back to while again. When we are back to while, we will ask, can we repeat? What is A arrow data now? Hello, A arrow data is 30. Check the picture. A arrow data, A is pointing to 30. And is 30 not equal to data that we are deleting? But data that we are deleting is 30. So not equal to condition is false. We have got our data. So the while will break. Yes, while will break. And after the while, we are checking is A equal to null. But A is not null because A is pointing to 30. A is exactly pointing to the node that we are deleting. We wanted to delete 30, isn't it? And A has stopped at 30. So A equal to null is false. Obviously, these lines will not run. And the next line is asking, is A equal to first? Is A pointing to the very first node? If A is pointing to very first node, be careful then. We will have to advance first to the second node. So we will have to deal this condition separately, isn't it? So we have written the condition separately. But listen, A is not pointing wherever first points now. A is pointing at 30. So this if is false. As this if is false, the else will run. And in the else we have written B arrow next equal to A arrow next. What that means is B arrow next, listen, B arrow next. B arrow next means 20 is next, isn't it? This is 20 is next where I am pointing. 20 is next was actually pointing to 30. But B arrow next, that is 20 is next, will point wherever A arrow next points. Who is that A arrow next? 30 is next, isn't it? And 30 is next is pointing to 40. So B arrow next will now point to 40. What that means is this association of 20 and 30 is broken. How can 20 is next now point to 30? Come on, 20 is next is now pointing to 40. That means the node now 10 is the first node, 10 will take us to 20, and 20 will take us to 40. So 30 is as good as deleted. This node is not in the list. But then after doing B arrow next is equal to A arrow next, we are calling free A. Check the next line. Free A will literally release the memory occupied by 30. I hope you got this. I hope you got this in and out, isn't it? This 30, the memory to which A points, is literally released. That's how we have deleted a node from a singly linked list. Enough, isn't it? After that free A, of course, the function ends. So all these local parameters and local variables are deleted. Okay. The only thing pending to be discussed is what is this? A equal to null. By the way, I hope till now you might have guessed it. Till now you might have guessed it, GATE students, that this A is equal to null will become true if we are bluffing, if the value we have asked to delete is not present. Sorry. If the value we are deleting is not present in the list, then this if will become true. Let's see. Let's see what we are talking about. So imagine that we have a list like this: 10, 10's next is 20, 20's next is 30, 30's next is 40. Okay, enough. 40's next is null, and first is pointing to the very first node. And suppose user says we want to delete 50 in this list. Nonsense. 50 is 50 is not present in the list. So what is the summary of delete? You know A and B, two pointers, will start at 10, the first. Then 10 is not equal to 50. We are deleting 50. So the while condition, A arrow data not X, will become true. So B will become equal to A. Anyway, B is equal to A, and A will become A arrow next. That means A will move ahead. It will point to 20. During the second repetition, we will again see that 20 at which we are is again not equal to 40. Again, we have not got the value. Sorry, 50. I'm so sorry. We are deleting 50. So B will follow A, of course. B will point to 20, but A will move ahead, isn't it? A will go to 30 in search of 50. Again, this value is not 50. I hope you are understanding. Then B will first follow A. B will point at 30 and A will move ahead. A will move to 40. Yes, everyone? So now what we have got is, we have come so far in the list in search of 50. We have come so far that B is now pointing at 30 and A is pointing at 40. Or really the things are becoming that where is 50? Where is 50? A is searching 50. And now when we go back to while, see A arrow data now is 40. Check the current conditions. And we are searching 50. So we still have not got the value. So we will go into the while loop and make B equal to A. B will become equal to A. And importantly, A will become A arrow next. This is it. This is it. If A becomes A arrow next, then A arrow next is null. You observe, it is null. So A will literally become null. A is a pointer and it will become null. As soon as A becomes null, this loop should break. This while loop should break. Then we should have one more condition written here. The condition should be while. So I purposely wrote this while loop like this. One more condition was supposed to be added. Now you will understand the importance of that condition. Well, this condition will be there, but the condition should become while A is not equal to null, A is not equal to null, and A arrow data is not equal to X. Well, anyway, this condition was there, A arrow data not equal to X. It is still there, but ANDed with logical operator AND. Now you watch, the while condition is going to become false because A not equal to null is false. A has become null. Just observe this. What's the way to ask this while? The question is, while A is pointing to a valid node. Observe this. It is so important. While A is pointing to a valid node. When will A point to a valid node? If A is not null. If A is not equal to null, we know A is pointing somewhere, isn't it? Only then we can go ahead, okay, then ask what is the data at that node. Is it not our data which we want to delete? If data at that node is not equal to data which we want to delete, then go to the next node, isn't it? But now what has happened is we have come so far that A has become null. As A has become null, the loop will break because A not equal to null is false. Listen, when this loop breaks, we are at the if, and we check first of all so carefully. We have checked, has A become null? I mean, we know that A started from the first node 10. A moved ahead, A moved ahead. Where is 50? Where is 50? And A has fallen down. A has become null. If A has become null, where is 50? 50 was not found. As A has become null, we will print cannot found 50, cannot find 50 in the list, and it's better to return back to main. Return will take us back to main without executing all the remaining code. From here itself, we are going back to main because the node was not found. I hope you have understood all the conditions in the delete node function. Thank you very much.